Alright, so here's my attempt at the practice test for you. Starting with question number 1. Henry purchased 3 ounces of Jawbreakers at 75 cents. Which graph best represents the relationship? Well, what we need to look for, if we were to make a table of this information, is our x and y. So x would be the weight, and we know that 3 ounces costs us 0.75 of a dollar. Okay, so what I'm going to look for is, with my graphs right away, I notice that graph 1 doesn't have a point plotted for 3 ounces, so I know that that one's incorrect already, just because there's no dot above the 3 ounces. Second graph, there's a dot above 3 ounces, but that represents $1.25, and $1.25 was not paid for 3 ounces, so we can move on. Number 3 is also incorrect. We didn't pay 25 cents for 3 ounces, because the correct answer is 4. You can see that 3 ounces is 75 cents, and we can break that down: 1 ounce 25, 2 ounce 50, 3 ounce 75, and if you were to continue that, 4 ounces would cost $1. So moving forward here. Alright, so with question number 2 here, let me get rid of this real quick. And so for question number 2, it says, what is the rule for the function represented by the table below? There are a couple different ways to do this. Probably the one that most students are going to choose is basically the guess and check. So what I mean by that is, if we just look at question number 1 and we look at our x value and see if our output comes out correctly, then we know we're doing it right. So for number 1, or option number 1, I guess, multiply the x value by -3. So if we take our x value of 1, multiply it by -3, we get -3. And -3 plus 4. So -3 plus 4 will give us +1. So it doesn't look like that one's going to work for us. And I guess I should write down the table here for you. That'll help you out a little bit. So we've got 1, -1, 3, 5. We'll just stick with these 3 for the sake of time. And so we know it's not option number 1. Let's take a look at option number 2. Multiply the x value. Multiply our x value, which is 1, times 3, and then subtract 4 from that. So if we simplify this, we get 3 minus 4, which gives us -1, and you can see that that does actually match our table. So let's check another one just to be sure. We're going to take our x value, multiply it by 3, and subtract 4 from that. So that gives us 9 minus 4 is 5. And actually, if you do this for your other 2 values, you will notice that it comes out correct. So that means for question 2, the correct answer is number 2. Okay. Moving on to number 3. We can see that the question is, consider the graph below. Which point represents the y-intercept? Well, since we know that vertical line is the y-axis, our graph crosses the y-axis at 1. So we know our y value has got to equal 1. So when we put that as an ordered pair, we know x comes first and y comes second. And that means our x value has to be 0 for our y-intercept, and that's always going to be the case. So correct answer for number 3 is option number 1. Moving on to question 4, it says a student recorded a temperature at 75 degrees Fahrenheit at hour 9 and 95 degrees Fahrenheit at hour 13. So you can see the graph below. So the question is, which calculation could be used to determine the average rate of change between these two temperatures? And hopefully that rings a bell for you. The average rate of change is exactly what we were doing for our velocity questions with distance and time. So it is strictly finding the slope from those things. So that narrows it down to option 3 and 4. And the values that were given to us were 75 degrees at 9 hours and 95 degrees at 13 hours. So the answer for this one is going to be option number 4. Don't overthink this one. Next, we've got question number 5, which is a graph, and it's asking us which graph or which equation does not represent the graph above. So a couple different ways to do this. There are 2 main parts for graphs, linear graphs anyways, our slope, which is represented by m typically, and our y-intercept. Okay, so as you look at the graph, just like the question before, we know that the y-intercept is going to be 1. Okay, we can see that on our graph that it crosses our y-axis at a positive 1 value. And our slope, without calculating it, hopefully you recognize, because it's pointing down and to the right, that it is going to be a negative slope. And you can calculate using rise over run that the value here will be, it's going down 4 for every 1 that it's going to the right. So our slope is -4. If we were to write an equation with this that we're familiar with, I apologize for the handwriting, I'm using my finger on the iPad. Y equals -4x, and we have +1 as our y-intercept. So number 1 is correct. It's a correct equation for that graph. Number 2 is the exact same thing. It's just written in function notation. And number 3 looks a little different, so we'll skip that one for now. But looking at number 4, there's a glaring issue with number 4 that's quite different, and that's this part right here. Our equation should have a negative slope, and option number 4 does not. That tells us it's a positive slope. So that one actually is incorrect compared to the rest of the function. So consider the graph below, which does not represent the equation. Number 4 does not represent the equation, so number 4 should be selected. Number 6 is very similar in that we're looking at an equation from a graph too. So our slope in this case, for every 10 that we rise, we go over 1. So our slope value is rising 10 for every 1 that we go over. And our y-intercept is, looks like it's right here at 10. So it would be our equation would be y equals positive 10x, because it's going up and to the right, plus 10. So in function notation, we simply put f of x equals 10x plus 10. The correct answer is 1. Number 7 might look a little more confusing, but we're still finding slope. We're just not finding it from a graph or from a table, but it's very similar. The process is exactly the same in identifying our rise over our run. Okay, so that's how we're gonna find slope. So let's look at these two ordered pairs, and we've got 1, 4, and -3, 9 is the other one. So if we look at the change in our rise value is represented by your y. So the difference between these two is going to go on top. So from 4 to 9, we go up 5. So our rise value is 5. And then our run, well, how do we go from 1 to -3? That's a drop in 4. So notice it's going downward 4 or -4. Unfortunately, 5 over -4, there's not an option for that. So let's rewrite this a different way. And we could write it as -1 and 1/4. So that's as a mixed number. Or if we want to simplify that and write it a different way, I guess I should say, -1.25. And if you look, option 3 is the correct answer for this one in that case. And lastly, for number 8, the question is, which generalization about the y-intercept for any equation is correct? Option 1, the y-intercept is located at the origin. Well, it can be, but it's not always there. More often than not, it's not at the origin, which is 0, 0. Option 2 says the y-intercept is at the point located on the x-axis. Well, no, that's the x-intercept where it hits the x-axis. So that one's not right. Option 3, the y-intercept is the value of x when y is set to equal 0. Well, if we get a value for x, that's going to be our x-intercept. So that one's incorrect as well. That leaves 4 being the correct answer. The y-intercept is the value of the equation when x equals 0. So what that means in an equation, plug 0 in for x, solve for your y, and that will give you your y-intercept. Okay. You'll notice that there were no x and y-intercept questions on this. I initially had some, but I realized that there was not a correct answer to those, so I deleted them for you so you weren't confused. So what I'd like you to do now is look at this equation and see if you can find the x and y intercepts from that. So go ahead and pause the video real quick. Okay, so I'm going to go ahead and solve this, and just like we talked about for question number 8, I'm going to plug in 0 for x. Oops, that's supposed to be an equal sign, sorry. And solve for y. So when we do this, we get y equals 6. So my ordered pair here is when x is 0, y is 6. That's one intercept. We take the same equation, but plug in 0 for y to get our x-intercept. This is where most students get stuck, and there are a lot of different things you can do here, but basically we need our x value alone. So what I'm going to do is get rid of 6 on this side by doing the opposite step. Rewrite my equation as negative 6 equals 2x because 0 minus 6 is just negative 6. And then finally divide both sides by 2, and our x value is negative 3. Okay, so that means our x-intercept is negative 3, 0. Let me give you one more real quick. All right, once again, I'll just give you an equation. 4x equals negative 7y. These will be some ugly numbers, but that's okay. Don't be afraid of them. Okay, so go ahead and pause the video, find your x and y intercepts. And so if I go ahead and solve this, I'm going to plug in 0 for x. And 4 times 0 is just 0, so we have negative 7y equals 25. Divide both sides by negative 7. Oops, negative 7. And our y value comes out to be 25 over 7 is acceptable. Sorry, looks kind of crazy. Like I said, it's hard writing with my finger. And it looks like that would be negative 3 and 4/7 if you want to write it as a mixed number is fine. Or if you have a calculator, get a decimal, or an improper fraction is fine in this case too. All right, solving for our x-intercept, we have 4 times x minus 7 times 0 equals 25. So this simplifies to just 4x equals 25 because negative 7 times 0 is just 0. Divide both sides by 4. X equals, what is that, 6 and 1/4. So since we wrote the other one as a fraction, we'll just leave this one as a fraction too. And those are your two x and y intercepts. Nice work. 2